Alright guys, this video is going to cover chemical and physical properties. We're just going to hit right into it. There's a lot of writing in this section of notes, so please feel free to abbreviate where necessary. Obviously, you don't need to write down all of these properties on the left side. These are just examples of different types of properties. The big things you need to pay attention to are the definitions on the right. So the chemical property describes the ability of these substances to undergo changes. So that's the big thing. Anytime you have a chemical property is the ability to change and transform into different substances. Some sort of chemical reaction must be performed in order to observe these properties. Great. Physical properties describe the substance itself. It can be observed or measured without altering its identity. That's the big thing. Any chemical properties allows it to change. Physical properties are just observations and measurements of the substance itself. So now we're going to take all these properties that are on the left, and we're going to characterize them. I know your notes, you've got just a little bit of space to write these down, so just write down a few of them. But you see on the chemical side, ability to, ability to, ability to, ability to, react, react, react. You see the difference. Those are telling you how the substance is changing. If it reacts with an acid or a base, the substance is changing. If it explodes, obviously it's exchanging. So anytime it changes substance or it describes the ability to change substance, that's your chemical property. Physical properties, on the other hand, they never change. It's always going to have a mass. It's always going to have the same density. That's a big one right there. Make sure you understand that. It's always going to have the same boiling point. So write a few of those down in those example boxes that you have. And pause it if you feel like you need to. Okay, now furthermore, we can take those physical and chemical properties and separate them further into two more categories called extensive or instantive. Extensive properties depend on the amount of matter present. So if I give you more of something, that extensive property will change. Intensive properties do not depend on the amount of matter present. Another big thing about intensive physical properties is that they can be used to identify a substance. Those are the big things. You can write down that, or you can just abbreviate as well. But then it says example 3.1. It's actually example 2 on the bottom right of your notes there, and we've gone ahead and separated them for you. But you can see the extensive properties. If I give you a gallon of gasoline, it's going to have a certain amount of energy. If I give you 10 gallons of gasoline, obviously it's going to produce more energy. If I give you a yard of yarn, and then I give you 35 yards of yarn, obviously you can make an object with a bigger area. A 35 yard is bigger than 1 yard of yarn. Okay, great. If I give you 1 marble, it's going to have certain mass. If I give you 50 marbles, the mass has changed. That's what we're talking about, is that extensive physical properties depend on the amount of matter present. On the intensive side, a drop of water will have the same boiling point as a gallon of water. It might reach that boiling point quicker with 1 drop, but the boiling point is still 100 degrees for water. It will always shine. If I give you 5 pounds of gold versus 30 pounds of gold, they're going to shine the same. If I give you 1 stinky sock and 30 stinky socks, they all produce the same odor. They always can conduct heat. If I give you more or take away less, they're always still going to have the same conductivity of heat. That's what we're talking about. I hope you see the differences with that. People tend to struggle with these two categories, but we'll focus on that a lot in class, so don't worry about it too much if you're not quite getting it yet. All right, guys, now this problem is probably not on your notes. If it's not, just go ahead and write it on the back or along those lines, or just keep another spare sheet of paper. Hopefully it's in your notes by the time we get around to this unit. But this is really good. It's going to go through several properties and a description of sodium in this case. We can give you iron or gold or silver, magnesium or chlorine. We can do this with any element. So you might see these a lot. So let's just go through these. All of the properties are numbered in the question, and we're going to separate them into physical, chemical, extensive, and intensive. So just go through them one by one. Sodium is soft. Okay? That is a physical property, so we'll mark that one right there. Okay, it's silvery colored. Great, it just describes it. It's an observation. Okay, so 2 is also a physical property. It has a density of 0.97. So far, they're all physical properties. That density is just an observation. Has a 2-gram sample. All right. So far, these are just observations. Nothing's really changing here. If sodium metal is ignited, it burns with a yellow flame. So now we're talking about flammability. You can go back and see that flammability is actually a chemical property. So we're going to put that down here, number 5. Number 6, it reacts vigorously with chlorine gas, which means it's going to change into something. And we can look back at our last chart, and we can see that ability to react is another chemical property. So 5 and 6 are chemical properties. So it forms sodium chloride, great. Then it has a melting point of 97.7 and a boiling point of 833. It's a high boiling point. Since we're boiling and melting, it's still sodium, so those are definitely still physical properties. So 7 and 8. So most of those are physical properties, just general observations about the piece of matter or the sample that they have been given. So now we're going to go into extensive and intensive. Now keep in mind these are extensive and intensive physical properties. Chemical properties we generally don't separate as intensive and extensive. So we're not going to include number 5 and 6 when we go through extensive and intensive. But let's go through it. Sodium is soft. If I give you 10 pounds of sodium and 50 pounds of sodium, the soft and the hardness doesn't change. So that's going to not depend on the amount present. So that's going to be an intensive property. Okay, number 2, silvery color. 50 pounds versus 10 pounds of silver. It's going to be the same silver color. So it does not depend on the amount. So it's intensive. Has a density of 0.97. It doesn't depend on the amount. Now this might confuse you people that are good with math, but we'll prove this to you in lab that the density doesn't change. And you can go ahead and play with the density formula, figure it out. But it's always the same for silver. It doesn't matter what's going on with it. So, anyways, it's an intensive property. It does not depend on the amount. Number 4, that's a 2-gram sample. Now I can obviously give a 2-gram sample or a 5-gram sample depending on if I give you more. So that's our first extensive properties, number 4. Okay, now it burns with a yellow flame. That was a chemical property, so we're going to skip that one. And it reacts vigorously. Great, that's another chemical property, so we're going to skip that one as well. Then we have the melting point. It does not depend if I have a drop of sodium or about 50 pounds, the melting point is always 97.7. So that goes back to another intensive property. The same theory, same logic applies to boiling point. If I boil 1 drop, if I boil a whole gallon of it, it's still going to boil at the same 883 degrees Celsius. So it's still an intensive property. There we go. Now once again, if this was a struggle for you, we'll do a lot of these in class. We can go through every element of the periodic table and give you one of these. And it'll start to click. I promise you that. And I'll see you guys in class.
Beautiful young female. Absolutely gorgeous.